Namaste everyone. Here is a problem. When 100 volt DC is applied across a coil, a current of 1 ampere flows through it. When 100 volt AC is applied and 50 hertz AC is applied into the same coil, only 0.5 ampere flows through the coil. Calculate the resistance and inductance of the coil. So here you have to add a sentence. So when 100 volt AC is applied, 50 hertz AC is applied to the same coil, only 0.5 ampere flows through the coil. Okay. Calculate the resistance and inductance of the coil. Remember, when a coil, if you want to develop any induced EMF across the coil, the current should vary. There should be a change in the magnetic flux linked with the coil. So if you have a coil, and if it is not a best coil, if it will have inductive effect as well as resistance effect. So suppose you can separate the inductor. Suppose this is a pure coil with a resistance R. That means I have separated the self-inductance of the coil with the resistance of the coil. Actually, they are mixed together. A coil, if it is not very good coil, it will have some resistance also. So when you connect DC across it, there is no induced voltage because this is a direct current and there is no change in the magnetic flux due to this direct current. So induced voltage across this is 0. And if at all if you get a voltage, then that is voltage across the resistor. They say that when 100 volt DC is applied, a current of 1 ampere flows to the coil. So 1 ampere. When 100 volt DC is applied, current of 1 ampere flows to the coil. And that current is only because of resistance effect, because there is no inductive effect, because it is a DC. So now, whatever you get is the resistance. So if you apply the Ohm's law, simply Ohm's law is enough, because there is no change in the flux, no induced EMF, no inductive effect. So simply I equal to V by R, or I can write R is equal to V by I. V is V is when 100 volt is applied, a current of 1 ampere flows. So current of 1 ampere flows. So this is 100 ohm. So resistance is 100 ohm. Now if you go to the second part, that is when 100 volt 50 hertz AC is applied to the same coil. This is a RL circuit, and it will have both inductive and resistive effects. So if I connect the same coil with some resistance like this to AC, now there is a voltage of, so total voltage of 100 volt 50 hertz, yes. 100 volt 50 hertz AC is applied to the coil. Current flowing is 0.5 amperes. So now it is an AC. So I can simply represent the current like this because AC has both the directions. So I don't mention any direction here. I equal 0.5 amperes. How this I has come into picture? It is an AC current. It is because of both inductive resistance effect and the impedance, reactance effect of the inductor. So now you have to write Z is equal to V by I. It is both the inductive reactance and the resistance, where Z is equal to root of R square plus XL square. R square plus XL square. So now Z is equal to V by I. V is 100 volt AC. I is 0.5 ampere. 0.5 can be written as half. So you can write it as 100 by 1 by 2. So that comes to 200 ohm. So Z is 200 ohm. The impedance is 200 ohm. Impedance is the result of both inductive reactance as well as resistance. So this is 200 ohm. Now their question is resistance. Of course, we have found out what is the inductance of the coil. So from these two, you can find out what is inductance of the coil. Okay, so you know the expansion of Z. Z is root of R square plus Z is equal to root of R square plus XL square. R square plus XL square. They want L, but we will find out XL and then we will go to L. Z square, if I write, Z square is equal to R square plus XL square. Z square is 200 square equal to R square, we know 100 square plus XL square. Now 200 square is 40,000. 40,000 minus 100 square is 10,000. 10,000 is equal to XL square. So that implies XL is equal to root of 30,000. You know that root of 10,000 is 100 and root of 3 is 1.732. So I can expand it like this. XL is equal to root of 10,000 into 3. So XL is equal to root of 10,000 is 100. Root of 3 is 1.732. So as far as possible, we will avoid calculator. XL is equal to, this is 173.2. 173.2 ohm. So once you get XL, you can find out what is L. Because you know the expansion of XL is equal to omega L, 2 pi nu L, and everything is given here, required things for 2 pi nu L. So XL is equal to 2 pi nu L. XL we have got it, 173.2 ohm. 173.2 is equal to 2 pi nu. Nu is 50 hertz, I think. It's given in the problem as 50 hertz to 50 hertz into L. Remember, this is 2 into 50 is 100 into 3.14 is 314. So 173.2 divided by 314 is L. So that implies self-inductance is equal to 173.2 divided by 340. That is equal to 0.552, you can write 0.552 Henry, because self-inductance is measured in Henry. So you have a curved path here. You have to find out one by one and finally arrive at self-inductance. There is no direct formula. First of all, from the DC circuit, you have to find out resistance simply by applying Ohm's law, R equal to V by I. Then from AC circuit, you have to apply Z by applying again V by I. So AC voltage by AC current gives the total impedance. From the total impedance, you disclose what is XL. From XL, you find out what is L. So one by one it is needed. There is no shortcut for this. Thank you. So finally, self-inductance is 0.552 Henry.